Number 9. So I've got h of x equals 4/3 x minus 2 when x is less than 0, and negative x plus 1 when x is greater than or equal to 0. And you said just the domain and range. Well, I have to graph it to get the domain and range. So nothing to it but to do it. Let's plug in 0. If we plug in 0, we get negative 2. Is that open or closed? Open. And then I plug in one smaller than 0, so maybe negative 1. Ooh, gross. Negative 3 is better. Negative 3 would give me negative 4, negative 6. Right? And then the second one, if I plug in 0, I get 1. Close. And then plug in one bigger than 0, so maybe 1, and I get 0. Second time's always closed. The only one that could possibly be open is the first. Unless you've got it between 2, then they could be open or closed. But if you're ever just doing one in the direction of, that one's always closed. Domain here. What'd you get for the domain? Yes. How about the range? Negative infinity up to 1. I'm looking at the y values. So this is as far up as I go. So bottom up. Which other one? Oh, Rich. Okay. A little bit. We're doing equations and inequalities of absolute values. X between 3 and 5 and negative 1 when x is 5. All right, here we go. This is one, I think, like you were asking, that has that middle one that goes between 2 numbers. But anyway, we'll start with 3. If you plug in 3, you get negative 2. Open or closed? Close. Smaller than 3, I get 1. First part. Here, if I plug in 3, I get 3. If I plug in 5, I get, both of these are open because this is sandwiched between 2 values. So I got 3, 3, and I got 5, 5. Nope, because it's got endpoints here. And then the last one, if I plug in 5, I get negative 1. And this is a horizontal line, so it just goes like that. All right, domain here, which I think was the biggest question with these. Yes. How about range? What's the lowest the graph ever goes? This is the lowest it goes. Up to what? You got it right. Did you? You know I posted the answers. Are you sure? And it said solutions, but it was. I just want to make sure. I know, Armando. I know. Is that it? Oh, thank you. There it is. So let me give you this to check, Rhett. They do it just a little bit differently on the domain and range. Did you get the graph of 11? All right, so let's look at the domain and range then. Domain. Left negative infinity to what? -1. And the reason is because at this point right here, they're both open. Okay? So it's going to be, I can't write on this, I wish I could. Negative infinity to 1. And that's the only value that I'm leaving out there. Oops, -1. Yeah. And then I pick back up, and I keep going. I've got another hole right here, but there's a closed-in spot here, so it just goes on to infinity. So -1 to infinity. There's the domain. And then the range from the bottom up. So what's the lowest it ever goes? Negative infinity. And where do you hit a roadblock as you come up? At 3. So I go negative infinity to 3. And then I pick back up where? Just at what? It's 5, right? And it's only 5. So here's what I'm going to do. I'm just going to say only 5. Look at you. All right. Y'all ready to move on? Let's Coach Beck coming back. Hey, y'all. I've been popping in over there every time. I did. I've walked over there twice. Yeah. I kind of forgot this last good part, yeah. All right. Tell me what absolute value means, first of all. That's right. That's right. It forces everything positive. It's technically distance, right? Like on a number line, distance from 0. Distance can never be negative. You can't run -2 miles. So I make it all positive. I just flip anything to positive. The symbols look like this, and anything can be inside. Rhett said -7. I'll go with that. It forces it to be positive. What happens if it starts out positive? It stays positive. So if this had looked like this, it would still be 7. Everybody okay? Right. Let's talk about what the graph looks like, though. It's a function. That's why I'm going to write f of x, absolute value of x. This is actually a piecewise function. When x is bigger than 0, so when x is positive, it's just the line y equals x, right? But when x is negative, it changes the sign and it flips it back over. So that's why it's in here with the piecewise function. I'm going to just show you how to do it for this one, and let me give you the parent first. If I think about a table of values, whenever I'm 0, of course that's 0. If I go on the positive end, 1, 2, and 3, my x value keeps the same thing, right? Because the absolute value of 1 is 1, the absolute value of 2 is 2, and so on and so forth. So, have y'all seen this before, by the way? You seen the graph of it? Oh. So there's half the graph. Now the other half of the graph comes in from the negative side, right? If I put a -1 into that equation, what does it spit back out? A positive 1, right? So this would be 1, 2, and 3 because it gives me the positive version of those. So at -1, I go to 1, -2, I go to +2, -3, I go to, It looks very similar to a quadratic. The only difference is I don't ease into that vertex. It just Boom, it's right there. It flips just at that very spot and has a sharp corner on it is what we call it when we get to calculus, it's a corner. So this is what absolute value looks like. What is the domain of this absolute value graph? Negative infinity to infinity. How about the range? What? 0 to infinity. Do you need a bracket or a parenthesis on the 0? A bracket. That point is filled in. It is included. All right. I'm going to give you a little easy way to graph these, or the way that I think is the easiest to graph it. When we hit transformations tomorrow, I'll show you an even easier way, in my opinion. What are y'all talking about? Oh, no, Rhett just keeps looking at Caleb and, like, laughing. Rhett won't see a punch in the face? Does that look familiar? That's right. That's right. And that's your vertex, or that point where it switches over. That's from our quadratics in vertex form, right? H is opposite. K is the same. Here's the only thing that's going to happen here that's a little different from our parabolas. You could have some number, I'll call it B, in front of the X. And if that happens, you have to factor out the B from X and H. And I'll show you exactly what I'm talking about in just a second. But if you can figure out the vertex, then when we graph it, all you need is 2 points on either side of the vertex. And that's how we're going to start by graphing, okay? So 2 points on either side. Yep. So let me show you what I mean. I don't want to leave y'all in 50 fast. I'll show you. I'm going to show you. On either side of, so whatever this H is, you'll go 2 above and 2 below. Yep. All right, let's do an example. Notice this one's got the number in front of the X, okay? So because it does, I'm going to have to factor it out of both before I even start. So if you factor that out, what does it look like? Divide by 2, that's exactly right. So really this is going to be absolute value of 2 times X plus 3. Does that make sense to everybody? Yes or no? Okay. All right, and so I can do this, and essentially what I could do is I could put that on the outside. You don't have to do that part, but just to show you why that's actually the A, and it's not, it doesn't go inside there with those. But anyway, here we go. What would my vertex be on this one? Negative 3, 0. Remember, it's H, K. H is opposite, K is same. Okay? Right. Okay. Tell me when you caught up with me. All right, so if my vertex is at -3, I want to go 2 left and 2 right from -3. So tell me what points I'm picking. -5 and what? -4. That gives me these two on this side, and then this side would be 2 on both sides, right? So if I'm at -3, I want to go 2 above and 2 below. Another one. Look in my middle desk drawer there. Like pull that middle drawer open. No, in the yeah, and to the right. Yeah. Armando needs look at me. Left. So I'll give you one. All right. So now plug into the equation, right? And be careful as you plug in, because anytime I end up with a negative, those absolute values are going to switch it. And it doesn't matter which one you plug into. You can plug into the original, you can plug into here, you can plug into here. It doesn't matter. I'm going to just go back to the original. So if I do 2 times -5 plus 6, that gives me -10 plus 6, which is what? -4, but I have to flip it over to +4. Right. Yes. You do the others. Let's see if we come back to the same thing. The nice thing about these as you're still working is that A still does the same thing that it did whenever I was in quadratics. It still makes me skinny, wide, up or down. Same kind of thing. Yes. Yeah. Easy? Okay. It's going to get a little harder, don't worry. What about the domain for this one? All of these will have the same domain, and it will be -infinity to infinity. How about the range? 0 to infinity. The lowest it goes is 0, and then it goes up forever. Y'all hadn't even asked about your quizzes from yesterday. I didn't grade them yet. Okay. That felt like some shade was being thrown at it. What? Okay. No shade was thrown. One more. How about if I make it like this? Here's the only thing that I will caution you against as you do piecewise that involve absolute value. If the vertex sits inside the range of numbers that you need, then you need to include the vertex whenever you cut it off so that it doesn't just look like a line. Does that make sense? I'll show you what I'm talking about. On this one, the first part's easy, right? I'm going to plug in 4. I get back out, what do you get? -7. I plug in a number smaller than 4, so maybe 3. And what do I get? Okay. -5. So I have 4, -7 with an open dot, and then I've got 3, -5 with a closed, and I'm going off. That's just a piece of a line, right? My problem is when I get to this one, this is not just a line. I might have to do more than 2 points. First thing I need to do is figure out where is my vertex. Look at that equation. Where is the vertex for that one? It is 3, 0. So my question is, does my vertex fall in this range of numbers here? No. So I don't have to worry about it. It's just going to be a piece. Does that make sense? Okay, where is 3, 0? 3, 0 is right here, right? But this is saying I have to be bigger than 4. 4's over here. So if I were to graph this, let me graph the whole thing and show you what comes out. If my vertex is 3, you won't do this for everyone. I'm just wanting to show you why this is what it is, okay? If I went on either side, I'd have 2, 1, 0, 1, 2. This would give me 1, 2, 2, 1, 3, 0. Because 3 is smaller than 4. So whenever I cut this off, I'm cutting off at 4, right? I'm cutting off right here. I don't need any of this. So once I graph the piece I need, it's not going to have that, it's not even going to look like an absolute value. It's going to be closed dot here, and it's going to go off. It literally just looks like 2 lines, even though it was a piece of an absolute value. Does that make sense? Now, if this had been reversed, okay, so if I had said x minus 3 when x is less than or equal to 4, I'm in a different situation, right? Because what that would look like is that would take this piece off, and it would go from here and all of this, and I wouldn't need the other side. Do you see the difference? The difference is which part I need. So you need to check to see, is my vertex sitting in this area or not? If it's not, then it's just going to look like a piece of a line. But if it is, it's going to make you pull a little bit more work into it. Y'all okay? Armando speaks for everyone. Let me show you inequalities and I'll be done. It's easy. Oh, I forgot domain and range. Yeah, let's do it. What's the domain, Armando? Negative infinity, infinity. How about the range? All right. I know this is a loaded lesson for today, but we went kind of light yesterday, so This is not my favorite thing to teach with these, but it's a standard, so we must. What does this look like? What's an inequality? That's exactly right. The greater than or the less than. So let's say I have something like, actually, let's make it. How in the world am I going to graph that? So a couple things that are a little bit different than whenever we graph just regular old inequalities. The first thing is, if you have a sign like this without a line under it, then my graph is going to be dashed. Okay? In other words, I do my absolute value and it comes out looking like this or like this. However it is, it can be flipped upside down. However it is, it's dashed though because I don't include anything on the line itself. Here's the other thing you need to know. If it's greater than or equal to, I'm going to shade up. I know, I'm sorry. Which means if it looks like this, I'm shading here. If it looks like this, I'm shading here. Did you? Well, your teacher very well could have made you do like test points to test to see which one you shade in and which one you don't. That's just hard. If you remember which way y gets bigger and which way y gets smaller, it makes it easier. If it's less than, I'm shading down. If it's greater than, I'm shading up. That's all you got to remember. So if you look at our example, will I be shading up or down on this one? Up, because it's greater than. Okay. So before I even graph, I know that I'm going to shade up, and is it going to be solid or dash? Everything else about graphing this is exactly the same as graphing the absolute value. What's the vertex? Careful. Why? You got to take that thingy out. That's right. So 6, -7. So let's do it. I'm going to put 6 in the middle so it's a little bit easier for me to see that I'm going up and down. Find your other point. See what happens. I'm going to give you a second to do it. I'm going to go ahead and start these going around also while y'all work on that. I apologize. I don't know how my printer got switched off of front to back. So take the top 2 and then pass it now. Those all. Yes. Always close on. Well, so it's going to be, you can use the points, but you're just going to dash the line in between. Yes, at the end. Yes. 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 Yeah. Yeah. 8 minus 12 is -4. The absolute value of -4 is 4, and 4 minus 7 is -3.
You're wrong.
You got to treat the absolute value signs just like parentheses. And then take the absolute value of them, and then you subtract the 7. I'm listening. Sure. Here's what I got for mine. Check yours against mine and see if this is what you got. I don't know why this stupid thing keeps doing this. Make sure it's dashed. And then we shade inside that and up. You don't have to worry about doing any range on these because we're shading.